All right, so we're getting on to the next unit. Going to be talking about weathering and erosion for this one. So weathering is different from erosion because there's no movement involved. That's, that's the one main difference there. So weathering is the decomposition of soil, rocks, and minerals. It's mostly just inorganic material is going to be weathered away. It's a result of direct contact with the Earth's atmosphere, so wind, water, things like that, cold. And there are two different types of weathering. There's physical weathering and chemical weathering. So we call physical weathering mechanical and chemical weathering biological. So this is an example of physical weathering here. It hasn't been like destroyed internally. So chemical weathering is going to be talking about like if you get some sort of bond with the rock and like an acid, it's going to bond, it's going to wear that rock away chemically. So it's actually losing its constituent parts. Whereas physical weathering, this is a really good example of it. It's just the physical attributes of that inorganic material. It gets weathered somehow. So this rock cleaved right down the middle. It was weathered by basically being cleaved into two different parts. So, it has half of the amount that it used to have. So that's a good example of physical weathering there. So physical weathering is the breakdown of rocks and soil, or the disintegration, and it's the result of direct contact with atmospheric conditions, so heat, water, ice, pressure, things of that nature, wind. And then chemical weathering is going to be the breakdown of rocks, soil, and minerals, generally by an acid. So an acid is going to be a solution that hits this certain rock. It combines with the elements inside of that rock, and then it pulls it away. So a direct result of atmospheric chemicals or biologically produced chemicals. So, physical weathering, we take a rock, we throw it against a wall, it breaks, that's physical weathering. If we drop some acid on a piece of sandstone and it dissolves, that's chemical weathering. So, here's a really good example of chemical weathering. So this is just water. Water comes down, it hits this sandstone or limestone, this is sandstone, hits this sandstone where it can kind of like build up. It's going to do that, and then it's going to interact with the chemicals inside of the sandstone. It's going to turn into a solute, which is just, it's basically just water mixed with something. So it takes a lot of the chemicals out of this sandstone, it weathers it away, and then we're left with these holes. And so then you can see in here, this looks like limestone mixed with some granite. Right in here, this isn't going to be chemically weathered because it doesn't interact with water the same way that this does. So this is going to be physically weathered unless you hit it with some acid or something like that. All right, so let's talk about erosion. So erosion is the removal of solids. So it's the removal of something from its source. So sediment, soil, and rock. That's what we're going to be talking about for this unit. So it occurs with movement, which that's the main difference with weathering. And they're going to be transported by wind, water, ice, gravity, and living organisms. So a lot of the times with erosion, water is going to take that sediment away. Eventually it's going to deposit it, and you're going to get like a delta or an alluvial fan. We'll talk about that within a couple slides here. And then when it goes down a slope very slowly, that's called a creep. If it goes down very quickly, that's a landslide. So remember that. If it's a lot of mud and water, then it's a mudslide. So, mudslides are just classified basically, I think it's 60% water. Essentially, it's got more water than a landslide, so it turns into a mudslide. And the main force with those weathering and erosion properties is going to be gravity. So it's bringing all of that sediment down, and it's going to deposit it probably at the bottom of a mountain. So creep is very slow. When you think of someone creeping, you think of either they're stalking you or they're really slow. So living organisms also do some erosion, like prairie dogs, or if there's a lot of worms in an area and they burrow, it allows for that area to be eroded a lot quicker. And then we'll talk about coastal erosion because that's a really, really big deal, especially in America today. So we talk about the Great Lakes, they have coastal wetlands. California has gotten rid of most of theirs due to just building. Washington, Oregon, all of the states on the coast, they have these things called coastal wetlands, which are really great because they are they naturally stop pollutants from getting into the water table, so they filter out a lot of pollutants. They are really good with flood control because it takes a lot more water to get through a wetland because it's constantly inundated with water. So these ecosystems are able to support more water than, say, a city with asphalt. Water's just going to go across that asphalt, no problem. If we have a wetland in front of that, the water is going to hit the wetland, it's going to sink into the soil, it's going to become inundated with water, and then if there's too much overflow, then it will go into the city. So we see a lot of degradation of cities because we lost the coastal wetlands. So New Orleans is a prime example. Katrina happened for a multitude of reasons, but one of the main ones was that they built on a swamp and they got rid of all of the wetlands around it, protecting them from certain flooding events. There's other things like deposition of materials on the levees that made them fail, that type of stuff, but wetlands are good. So coastal erosion happens to wetlands, coastal wetlands, and that's just the wearing away of the land, the beach, or the dune sediment, which kind of just like holds all of that stuff there, basically. And it's caused by waves from tides, winds, storm sects, and human activity. So here's just a really good example. We had this wetland right here. This grassland here is technically a wetland. It looks like it's a riparian floodplain, which means that during certain seasons, during certain cyclical events, this area will become inundated with water from the ocean, and it will kind of seep down through that grass there and kind of be filtered, and then it will eventually go back out into the ocean. But what we did was we got rid of all of that wetland right next to the sea, and vegetation holds stuff together as well. We got rid of all of that, and then we put a big road right in front of it. And so eventually what happened was these cliff sides got weathered away by the continuous bashing of the water onto it, and it weathered away, and then you lost big portions of this road. And so then you see down here, this is all asphalt. So not only have we destroyed this whole area unsuccessfully, but we've also polluted it with asphalt. So that's not so great. Okay, so natural erosion is generally an okay thing. It's caused by natural phenomena in the atmosphere, so we're talking like rain, wind, rivers, ice, glaciers, waves, or currents. A lot of the times, the higher you go in elevation, the colder you get, and the more water there is, you're going to have more weathering properties. So that's just something to think about. And then the effects of natural erosion are widened valleys. So, this can be either due to glaciation, glaciers retreating create valleys, or rivers, and then rains into the rivers. So rivers create valleys as well. And if there's sediment in there and they get eroded, then those valleys will widen. Alluvial plains or alluvial fans. And essentially what this is, if you look on a lot of mountains, if you see an area where that stream goes down the mountain, eventually there's going to be a point where that stream stops, and it kind of looks like this, and then it expands out at the bottom. So it's basically just a lot of erosion has happened to where some water can go down a mountain. That water is going to bring a bunch of sediment down the mountain due to weathering and erosion, and then it's going to deposit it at the bottom of the mountain. So you get this delta-like effect. It just kind of, that river goes down and then it spreads out all of the sediment at the bottom of the mountain there. So that's an alluvial plain or an alluvial fan. It also creates fertile soil. So farmers every season need to till their crops and rotate their soil so that they have more nutrient-rich soil at the top for topsoil. And natural erosion does that for them. So if you think about the Nile River, every season, prehistorically, people used the Nile River as a way to create a more fertile environment. So they call it the Fertile Crescent in that certain area too. And so that's why. Then natural erosion creates beaches and desert sand. Essentially, when rocks get subjected to erosion, they get smaller and rounder. And so that's what like sand particles and desert sand are. They're just continuously being eroded. They can be caused by animal activities like grazing and herd movement that can just, erode a whole area full of grass. And those effects will be reduced vegetation, which will increase erosion because vegetation holds the earth together. Topsoil exposure, so all of that top layer is going to get washed away, and then you're going to get topsoil, which is the best soil, and that will be washed away as well. You're going to lose seed germination. Just again, they're getting washed away because they're being exposed. And natural erosion can be caused by a lot of catastrophic events like volcanoes, hurricanes, earthquakes, tornadoes. They just kind of devastate an area and erode it. And then effects of natural erosion, you can have excessive erosion, and then it can create a positive feedback cycle where it just continues to erode worse and worse. That will damage the ecosystem, and then that whole area will be incapable of farmland because you lost the topsoil, you lost the seed germination, and you lost the vegetation. So that's kind of what happened with the Dust Bowl, but that was human impacted. So artificial erosion is worse than natural erosion because generally humans tend to increase the rate of things happening. So here, human activities speed it up. So farming, boating, urban development, road construction, deforestation, off-road vehicles, hiking trails, all of these things lead to an increased rate of erosion in the certain system that they are in. So hiking trails are there for a reason. They've already been eroded. The hiking trails have already eroded that area. So that's why we want you to stay on the trails, because if you leave the trail, then you can start to erode another area, and then you can cause that area to go into more erosion due to that positive feedback loop. So here's just a nice little picture of a hiking trail just eroding. There's no vegetation there. This is all erosion. It's going to create an avenue for water to go down, which will erode it even more, and then the areas around it will eventually become eroded as well. So erosion rates for artificial erosion are 10 to 15 times greater than natural erosion, and sometimes even more. You get an extreme loss of fertile soil. That's going to be like the Dust Bowl. You're going to get an increased demand for food with the loss of soil, and you're not going to be able to meet the food needs for a population. So that's exactly what happened with the Dust Bowl and what spurred the Great Depression. So that's just something to think about. So with rates of weathering, we've got differential weathering, which is just essentially soft rock weathers faster than hard rock. So the soft rock will weather away, and what's left is the harder constituent parts. With more surface area, you're going to have faster weathering. So surface area I want you to think of is the amount of outside material an object has that's able to be weathered. So volume is the inside. So if you have something with low volume but high surface area, it will erode faster than something with high volume and high surface area. So a small rock will erode faster than a big rock because it has more on the outside than it does on the inside compared to the big rock. Elevation, like I said before, with higher elevation, you get faster weathering, and especially with more wind, water, and ice. So they're colder up there as well. And then climate. So higher temperature is going to increase weathering. Lower temperature is going to increase weathering with like ice events. And then more water is going to increase weathering. And then faster water will increase weathering as well. And here is a picture showing you, this is like Goblin Rocks in Utah. This is differential weathering. So down here, this is all softer rock, and then this is hard rock. So this has all been weathered away, and what's left is this weird-looking mushroom-shaped rock formation. So that was pretty quick, but that was all of it. So go ahead, watch the video a couple times if you need to, and make sure you have that PowerPoint open when you're doing the quiz. Also, if you have a question, make sure to ask me, especially if it's on the quiz. I can point you in the right direction. Have a wonderful week.